Welcome to this presentation on convolution theorems. We will show that the convolution is commutative, it is associative, and that it distributes over addition. We will also point out the implications of these theorems. Let us first take the property of commutativity. U convolved with G of n equals G convolved with U of n. That is, the order of convolution does not matter. What does this asterisk mean? Okay, here we are. This is the meaning of this asterisk. Remember the infinite sum. When these two arguments are added, you get n. This is the value we had for y of n. And the limits go from minus infinity to plus infinity. Substitute r to be n minus k, this becomes g of r, and I get u of n minus r because k is n minus r from here. If you substitute k equals minus infinity, r becomes plus infinity. So this goes from plus infinity to minus infinity. We can change the order in which they are added. So I get this, and this is nothing but g of r into u of n minus r, because g and u are scalars. So it is understood that we are talking about scalar values for both g and u. If these are, any of them is a matrix, then you have to be careful about it. If it is a matrix vector arithmetic, then you have to be careful. When both are scalar, you can change the order of multiplication. So this is nothing but Gn convolved with u of n, which is the right hand side. So we have shown this equality. What is the implication of commutativity now? The order in which they are multiplied does not matter. So the input and impulse response can be interchanged. This property does not hold if one of the sequences is either nonlinear or time varying or both. This property also implies that impulse response and the input can be interchanged. Here is a system where the input is u, impulse response is g of n. Here is another system where the input is g of n and the impulse response is u of n. The values are the same. The next property is that the convolution is associative. Here what we say is, you convolve these two first and then you take this convolution. Here it says that you do this convolution first and then this convolution. So by LHS I mean the left hand side. Let us evaluate this. Recall what this convolution means. We expand it in terms of this infinite sum and then apply the meaning of this convolution, where you take this r and you take this minus r here. Let us evaluate the right hand side. We explain the meaning of this, then it is infinite sum convolved with g of n. Then you substitute k here and then you have the remaining things, and notice that this is nothing but what you have here. So this is left hand side. So we have shown that the convolution is associative. What is the implication of this rule? The left hand side can be illustrated by this picture, where you give this input u of n. Inside the system you have g1 convolved with g2, and this u of n has to be convolved with this whole thing, and you get this y2 of n. Whereas the right hand side means this. First you do the convolution of u of n and g1 of n, you call this w of n, this whole thing is w of n, and that becomes the input to g2 of n, and you evaluate this, you get y1 of n. So this is y1 of n, this is y2 of n. What we are saying is y2 equals y1. As a result, we can write this without brackets as follows: the order in which we carry out the convolution does not matter. The next result is that the convolution distributes over addition. Okay, I have written the left hand side, which is u of n minus 1 times this whole thing. I have written it here. Now you multiply inside, so u of n minus r into g1 of r plus this multiplication. It is because this multiplication distributes over addition. These are all scalar arithmetic, we can do that. The first one is u of n convolved with g1 of n, and the second one is u of n convolved with g2 of n. So we have shown the right hand side. What is the implication of this result? The left hand side is this, where we add g1 and g2 for every n, and un is the input, you get this y1 of n. What about the second one? You first convolve and then add them. You first convolve and the results are added. So this is y2 of n, this is y1 of n, these two are equal. Why are these important? These will be useful when we design controllers using Z transform. We use such results in continuous control also that are based on Laplace transform. We will use these results repeatedly in this course. That brings us to the end of this presentation. Thanks for joining.